All right, so in our last journal, Journal 9, we talked about graphing absolute values and how, like, depending on, what's inside that absolute value, it tells us which way it shifts. And if we have something outside our absolute value, it also tells us a certain types of shift. So we're going to summarize that here today. So no bell work. I want us to focus on taking what we learned in the last journal and summarizing it. So in this case here, we talked about when it's inside the absolute value sign, it is our horizontal shift. So whether it goes left or right. So something to keep in mind, and when it is a positive sign on the inside, you actually move to the right side of the x-axis. So you move right. When it's a positive sign, you're going to move left. And then when we have a outside of the absolute value, that's your vertical shift. So in this case here, if it's a plus sign, you go up. If it's a negative sign, you go down. And that's your vertical shift. And then we have the slope, right? The slope here is the number or coefficient next to the x. So in this case, a here is representing our slope, because in this case, the slope could have been whatever number it wants to be, so just put in an a to represent that number. I also want to mention here, based off your shift, that will determine where your vertex will be, right? So in this case, this is telling us our shift that is moving left or right. And so h here tells us our vertex value for our x, whereas our k shifts up and down, so that's shifting on our y-axis, so that's going to, k is our y value here. Oh, sorry, I think I wrote an x, but I meant to write, oop, my bad. Let me fix that real quick. So that should have been a h. H and k are our vertex. Now, I don't need you to remember this part. I do need you to remember what are the different types of shifts. So you need to know that when it's inside the absolute value signs, that you're shifting either right or left based off the sign, and when it's outside the absolute value, that you're shifting up and down, and that the number in front of x is your slope. Those are the things I need you to know. The vertex you can easily read after you plot your vertex on the graph, after you know what the shifts are. So we're going to do some few examples here. I want you to turn to page 4 of your packet and do these problems with me. So I'm going to show this in the next slide. All right, so we're going to start with number 4 here. So the first thing we're going to do is evaluate this function, and I want you to figure out what is the shift here. So take a look at your absolute value here. When it's inside the absolute value sign, that tells me that it's either going to shift left or right, but I see a plus sign. So a plus sign means that I'm going to be shifting left. In this case, left 1 unit. So if I'm shifting left 1 unit, that means I'm going to, remember, we start at the origin here, and we're going to be going left. So that's going to be this way. So the vertex always starts at the origin, and then you're going to make your shift based on what your equation says. Now, I've shifted left, and I don't see anything that's outside the absolute value besides the 2, but I'm looking on this side here because I'm looking if there's a vertical shift, and there isn't. So I have my vertex plotted. There's no vertical shift, so it's just moving it to the left. And that vertex right there, the coordinate for that looks like -1, 0. All right? And then, so we have our vertex. I'm just putting a little v there to remember that's a vertex. But I need to draw my v for my absolute value function. So I need 2 more points. And if you remember last time, what we did to try to find the 2 more points is using the slope. So my slope here is 2, or I can think of it as 2 over 1. And so I would go from my vertex, and I would go up 2 over 1. And then I would try to draw my line. But remember, if we're drawing a V, we need a line that's symmetric, or the reflection of that. So I have to go up 1, but now to the left to reflect that. And then I'm going to draw my lines. And so this here, the vertex here, is the lowest point on the graph. So this here is going to be our minimum. Our vertex is the minimum here. And that's it. So remember that our absolute value, you have to plot 3 points to make sure that you actually draw the correct graph. So again, we're going to do 5 here. We're going to look at the shift. So this inside says a -2, so we are shifting left 2, and then, sorry, not left 2, my bad. Oh, what am I saying? If it's a negative, we're going right 2. And then notice how outside here there's a +6. That's going to tell me my vertical shift. So a +6 is saying that I am going up 6. So I'm going to be starting at my vertex, and if I go right 2, up 6, that's right there. So here's my vertex, right? Or let me be consistent. So this is my vertex using the green one. And I need now my slope to find the other 2 points. So my slope here looks like it's -1, right? -1. So -1/1. So this time, instead of going up, I have to go down 1 over to the right. So down 1 over to the right is right here. Let me do a pink one. And then I can connect the dots, and then I have to go down 1 over to the left to reflect it. And so there we have our V. And my vertex I didn't write here, but it was 2, 6, right? 2, 6. And then this here, now the V is like upside down, so this vertex is actually the maximum because it's the highest point on this V. So this here is maximum. All right, let's try one more here, number 8. I kind of put it off to the side here. Let's see if I can shrink these two. Maybe I can. Ooh. Or, you know what, I'll just kind of throw them to the side here. You guys don't need that anymore. Yeah, let me just throw that to the side so I can make 8 a little bit bigger for us. All right, so for 8 here, when I'm looking at this one here, I notice that this shift is a +3 on the inside, so that's going to be left 3. And then the outside has a -2, so that's going to be down 2. So in this case here, if I'm going left 3 from the origin and then down 2, it's right about there. So I'm going to plot that vertex. And that vertex looks like it's at, I just put a little V there to remember that's my vertex. It's my -3, -2 for my coordinate. And then my slope here is this 1/2, so I already have my rise over run. So in this case here, I have to go up 1 over 2. So if I go up 1 over 2, you'll notice that this line here is not as steep, and then I have to just go the other side to reflect. And so, again, my vertex here is the minimum, right, because it's the lowest point. So I'm going to circle, or just write minimum here. You can circle as well. And that's it. So hopefully that gives you a better idea of how to do these homework problems. So try the other ones. Okay, now we're going to talk about graphing linear inequalities. So to graph linear inequalities here, what we're going to try to do is there is a 3-step process, okay? To graph linear equalities, something like, I'll give you a quick example here. So something that's a linear equality would be something like x plus 1. Let's make this a 3 here. So this is what I would call a linear equality. It looks like a linear function like the mx plus b, but instead of an equal sign, there is an inequality sign. And we need to be able to graph this. And it's kind of like graphing a line, but a little bit different. So the first step is to solve for y, which means you need to get it by itself. The reason why you want to do that is when you get it by itself, then you can see it as y mx plus v, and so that way you can use to plot your intercept and your slope, so you can make those 2 points on the graph to connect the dots to make a line. So you solve for y so that way you know what your slope is and what your intercept is. That's why we have to get y by itself first. Once you have, the y by itself, you're going to graph the line, and when you're graphing the line and connecting the dots, keep in mind if there's an equal sign on that inequality like this one, you're going to use a solid line like this. Whereas if you don't have an equal sign underneath, you're going to use a dashed line. Kind of like how we have open circles and closed circles. That's the case here when it comes to graphing. And third step here is about the shading. whenever you have something that is like y greater than, so it's facing the y, so the y is bigger, you want to shade above the line. When y is less than, you want to shade below the line. So now that I've talked about my 3 simple steps for graphing linear inequalities, let's put this into play and do some problems from page 3. Oh, not page 3, page 5 of the packet. So turn to page 5 of your packet, and we're going to try out some problems here in the next slide. Okay, so let's do some example problems from page 5, the packet. So I've chosen problem 1 for us to start with. And so in this problem here, notice how we need to first check to make sure that the y is by itself, and it is. So this side here, I can clearly see what's my slope and what's my intercept. So my slope here is the number in front of x, which is negative 2 over, it would be over 1, right? So I have the rise over 1. And then b here is negative 2. So if I were to go to my y-axis, I'm going to plot my b, which is at negative 2, so right there. And then I'm going to go down 2 over 1. And then when I connect the dots, create a solid line, right? So in this case, notice how I have to draw a solid line because this inequality right here has an equal sign in the bottom. So this needs a solid line. So keep that in mind when you're about to connect those points. You need to check the inequality to make sure, do you need a dashed line or do you need a solid line? And now I also notice that this inequality is saying that y is greater. If y is greater, that means you want to shade above. So the reason why we want to shade above is because y, if it's greater, it wants to be in the upper part of the y-axis, right? So numbers where y are greater are positive y values. So that's why I want to shade above this line here. Now, if y was less, then I want to go below this y-axis. So that means that I'm heading towards negative infinity for y. So I want to shade in this lower part of the line. Okay, does that make sense? So when we're talking about whether y is greater or less than, we're talking about the y-axis and what quadrant they're in. So that way we know we need a shade either above or below. Okay, now this one here, notice how the y is not by itself. The y is right here, right? So I need to try to get it by itself, so I'm going to try to move over the thing that's further away from y, which is the x, so I have to move that over. So that cancels out, bringing down, oops, sorry, oh no, no, okay, there we go. So I have 3y that drops down is greater than 3 minus x. So now what I need to do is get rid of the 3. Here's the only thing I want to mention here. When you divide by 3, you have to divide each term on the other side by 3. Okay? So that means that 3 gets divided by 3 and that x gets divided by 3. So 3 divided by 3 is just 1 minus, so if you take a look at this x here, the number in front of this x is a 1, right? Or a negative 1 if you count that minus sign. So remember, the x is the one that holds the slope. So instead of writing it this way, right, we can write it as negative 1 over 3, or 1/3, in front of the x. So that way we clearly have defined what our slope is. So it looks like my intercept, my slope is negative 1 over 3, and my intercept had to have been this 1 here. So I'm going to grab that. And so if I go to my y-axis here, I'm going to plot at 1 right there on the y-axis. And then I have my slope, which says negative 1, 3. So that means that I have to go down 1. Oops. Down 1 over 3. So right there. And this time, notice how you need a dash line, right? This inequality doesn't have an equal sign underneath, so we're going to dash it. And that's going to look something like this. And so this one also says y is bigger, so we want to be in the positive y region. So I'm going to have to shade above then, above this inequality line. Okay, and I think that's it. So let's take a look at 2 more problems from this page. Okay, so these problems are pretty interesting, number 2 and number 6. So the problems down below that page. So first let me just point out, this is just an x by itself with a number that's on the other side, right? So remember that equation where there's x equals some number, right? And I asked you guys what type of line this made. And you guys might remember that it makes a vertical line, right? And well, it's the same deal here. We're graphing a vertical line, but we just have to understand the inequality. So in this case, if I were to think of this as x equals -2, this is saying that I need to go on the x-axis. So I'm going to go on the x-axis. So here's my x-axis. And I have to go to -2. And the thing is, I need all the -2's in that axis, which is all of these values, right? So that's why I'm going to make a vertical line. And I need a solid line, right? Because that there has an inequality with an equal sign. So solid line I draw. I'm going to grab my highlighter here. So notice how this x says it's greater than -2, right? If we were to look at this from the x-axis perspective, we're either shading left or we're shading right. So because x is greater than 2, we want to shade in that positive x direction. And so that means we are shading right. Okay, all the stuff on the right side. So that's when if you have x is by itself with just a number. Now if y is by itself, like this case, and it equals a number, this is what we call the horizontal line. So the horizontal line, my bad, we're going to have to draw on somewhere on the y-axis. So we're going to go to the y-axis this time and plot it at 5, which is about right there. This also needs a solid line, and we need all the y values at 5. So this is going to be that horizontal line that I'm going to draw. And so this is a solid horizontal line. Now, the next thing I need to know is figure out where am I going to shade. Now, this says y is less than 5. If y is less than 5, the y values that are less than 5 are down in this direction, right? So I want to shade below it. If I shade above it, that's going to be greater than 5, and I don't want that. So I'm going to shade below this. Okay. All right. So we've done quite a few problems with inequality now. I want us in the next slide to turn to page 6 of your packet and to try out problems where we're fusing together the idea of inequalities with absolute value signs. So let's head over to page 6 on your packet. Okay, so this is page 6 on the packet. And notice that now I have absolute value signs that I'm graphing. So keep in mind, I'm going to be graphing a V-shaped graph. So we are graphing a V shape, whether it's going to be a minimum or maximum, we don't know yet. So with these problems here, if I were to graph them, let's go to this one here. So if I were to graph this one here, I first have to figure out when I'm graphing them, am I graphing them, like what's the shift, right? Because I got to graph that vertex. So looking at this, I have a -5 on the inside. So remember, the inside tells us the horizontal shift, whether it's going left or right. So if it's a minus sign, it is going to be going right 5. So if I'm going right 5, I'm going to be going this way, and then I'm going to plot right there. So that right there is my vertex. And then I use my slope. So the slope here is just a 1 over 1. So from the vertex, I'm going to go up 1 over 1. Which is right there. And then if I want to draw my other line, I just reflect it. So up 1 over to the left. And oops, I didn't draw the right type of line, right? So this inequality is a dash line. So that means I have to go back and make sure that I draw myself a dash line here. So I'm going to go back and erase that so I can make that a dash line. So we're going to use a dash line instead of a solid line here, because our inequality says that we need to have a dash line based off there's no equal sign here. So now we have to figure out our shading, okay? So it says y is greater, so we know we're shading above. So what you want to do is just a shade above the v, okay? Above the absolute value line or above those lines that you're seeing. So that looks like we're shading above the v, so like this section right here, okay? All right, so let's take a look at our next number here, number 11. So we're going to do the same thing. We got to figure out a shift. So inside here, that absolute value is saying plus 3, so that is saying left 3. And then that number out here is saying minus 1, so that means I'm going down 1. Remember, the outside number tells you your vertical shift. So if I follow this here, left 3, down 1, that's right there on the graph. So that's my vertex. And then I have to use my slope. So my slope here is 1 over 1, right? So if I'm doing 1 over 1, I have to go up 1 over 1. There I am now. And this time I still need a dash line. So I'm going to make a dash line here. And then I need my other points, so I go up 1 over 1 and make a dash point or dash line. And then, okay, so this inequality didn't have a line, so that's why we made a dash line. And it says y is greater than this function. So if it's greater, I'm going to be shading above as well. Shading above this line or this absolute value line because I want positive y values if it's greater than. Okay, that's it, guys. So now you should have all of the video content for being able to do the problems between pages 1 through 6 on the packet, okay? So make sure you go back to the other videos if you're having a hard time figuring out what to do. Okay, that's it, guys. Have a great day.